This is the second of my talks on the labour theory of value. Like the first, it is intended to be given in Belgium next month. In this part of the talk, I'm going to be talking about the transformation problem, something which has long been seen as a difficulty with the labour theory of value. And I'll go on beyond that to explain what the actual mechanism is that enforces the law of value. Now, what is this transformation problem? Transformation problem stems from an assumption that David Ricardo had made. Ricardo had assumed that the labour content of a commodity determined its price, but he also made another assumption, which was that the rate of profit in all industries will tend to equalise. But if profit comes from labour, then labour-intensive industries would have to have a higher rate of profit, which would contradict Ricardo's second assumption. Now, Ricardo did some calculations to the effect that he expected prices to be something like 93% determined by labour content, and that the effect of profit equalisation would be at most to introduce a 7% error. Well, the empirical data actually shows that labour theory of value gives somewhat better accuracy than Ricardo had anticipated. But in the 19th century, before any empirical data had been collected, this was seen as a serious flaw of Ricardo's theory and helped to discredit it. Marx claimed that he had a procedure to transform labour values into profit equalising prices. Basically, he assumed that surplus value was redistributed towards capital-intensive industries. But later on, towards the end of the 19th century, economists pointed out that the examples Marx had used were very limited, and if one generalized it, there was a logical flaw. The situation had become such that by the 1960s, Samuelson, who I've mentioned before, said that all that you had to do in order to transform labour values to prices was to take out a razor and rub out all references to labour from Marx's argument, and then you'd have a theory of prices. But until the 1990s, nobody had actually bothered to see whether profit equalising prices or labour values gave a better prediction of real-world prices. Once people started to do this, it became clear that profit equalising prices are actually not any better than labour values in predicting real prices. David Zachariah has done a multi-year study looking at the relationship between prices, market prices, labour values and profit equalising prices for all the OECD countries. And he shows that sometimes labour values give a better prediction and sometimes production prices give a better prediction. So there is no clear advantage to the production prices. Now, why is this? Once you look at empirical data on the rate of profit for different industries, you find that Ricardo's basic assumption is not met. I've got a plot here of, on the x-axis, the capital labour ratio of various industries in America, and on the y-axis, their profit rate. Now, according to Ricardo's assumption of profit rates equalising independently of the capital labour ratio, they should all lie around this dotted line. If, on the other hand, the straight labour theory of value applies, you would expect the profit rates to be higher in those industries which had a low capital to labour ratio, and for the profit rate to fall off in the industries which do have a high capital to labour ratio. Now, the dots are the empirical data, and you can see that this line predicts the results a lot better than this line, which is what the simple labour theory of value would predict. But it's not what a profit equalization theory would predict. So why is it? We know that the labour theory of value is empirically true. There remains the problem of explaining why it is true. And we didn't get an answer till that until a couple of mathematicians started to apply the methods of statistical mechanics to the problem of the law of value. And this was laid out in a book called The Laws of Chaos, which was published in 1984 by two mathematicians, Farjun and Markova. Okay, Farjun and Markova give a statistical argument, and rather than deal with formulae, I'm going to show it to you by using a simple graphical diagram. So I start off by drawing an XY axis here. We then say, what are these axes? Well, the vertical axis is the probability of something occurring, and the horizontal axis is the ratio between the price of something and the integrated wages required to produce it. Now, the integrated wages are the wages required to produce it directly, and then the wages of all that were required to produce all its components. So it is something very similar to the labour theory of value. The integrated wages are very similar to labour contents. Now, they argue that in a chaotic system like the capitalist economy, the ratio of price to integrated wages will be normally distributed. It'll fall on a bell curve like this. The diagram I've shown shows a mean of about 1.5, which is what we find empirically. They had suggested the mean of this distribution would be 2. In fact, it's somewhat lower than that. It would be 2 if, in Marx's terms, the rate of surplus value is 100%. If the rate of surplus value is 50%, you get a mean of 1.5. Why is it normally distributed? Well, normal distributions occur widely in phenomena that we measure, and in general they exist in any phenomena which is the result of a sum of many independent, semi-random or random causes. And a chaotic system like capitalism means that a given price is bound to be the result of many independent processes acting at once, which are uncorrelated, and therefore you expect a normal distribution. The question then comes is, what is the mean of the distribution, and how widely spread is it, or what is its standard deviation, which are the two characteristics of the normal distribution? Well, if the thing is too spread out, you will find that there's a certain probability that firms have a psi less than 1. Now, a psi less than 1 means that the firms are selling a product not only for less than what it cost them to make, but less than what it cost or them and all their suppliers to pay in wages. So that's a very unlikely situation for a price to be that low. The firm will certainly fail if it's selling things at such a low price. So this is what I've shaded off here as the zone of bankruptcy. Now, how many firms can we expect to be in this region? Well, in the diagram I've said, okay, I've assumed less than 5% are in this region. Well, that's a very generous assumption. They assume it's a much smaller percentage than that. But the basic assumption is that a very small percentage will be in the bankruptcy zone. The effect of that is to squeeze this normal distribution so that only a small part of it occurs in the bankruptcy zone. They predicted from this that they could deduce what the standard deviation of this normal distribution was going to be, and from that they could calculate what the expected degree of correlation between prices and labour content was going to be. And they predicted the sort of high correlation that was actually observed. Now, all the empirical studies I've cited earlier, occurred after Farjun and Machover had made these predictions. So it is therefore a very strong scientific prediction. They'd made a prediction on the basis of theory, which was quantitative, and when people carried out the measurements, it was found to be true. They also predicted that, contra Ricardo, profit rates would not tend to equalize. This was a result of their applying the formal methods of statistical mechanics, which were developed to analyze gases, which are a chaotic system with many, many, many independent variables, being the positions and velocities of the molecules in the gas, and applying that kind of mathematics to the capitalist economy, rather than applying deterministic mathematics, which is what economists had applied before. Now, here is some data that Zachariah collected, which plots the actual distribution of the price to wages ratio and plots it as a probability distribution, and he compares that with Farjun and Machover's prediction, which is the dotted line. And as you see, Farjun and Machover overestimated what the mean was going to be. The mean is somewhat lower. The effect of making the mean lower is that the whole distribution gets squashed and gets narrower, so that actually the correlation between prices and labour values becomes stronger. Marx said he was working on trying to understand the laws of motion of capitalism. Now, that's a physics metaphor. It's arguable, I think, that there are quite a few physics metaphors in Marx's analysis. It's arguable that his analysis of the value form is based on what in physics we would now call a symmetry or conservation law principle. But this work by Farjun and Machover was the start of what's now called econophysics, and it is the systematic use of modern physics, mathematics, and statistics to say things about the laws of motion of capitalism. The great thing about it is it makes prior quantitative predictions, it makes predictions that allow for empirical testing, and it's been verified by tests. And it's therefore an outstanding example of modern Marxist science. It applies the scientific method in its full rigour and produces strong results, strong testable results. The lessons we draw from this are that the basic hypothesis of the labour theory of value is strongly borne out. The value of output of an industry is 95% or so determined by the direct and indirect labour used to produce that output. The old argument of socialist economists from Gray to Marx that profit is based on exploitation is justified. And the labour theory of value itself should be the basis of all socialist economics.